Today we've been working with slope-intercept form all last year and a little bit this year. We should be super comfortable with it. We'll probably have to go back at some point and go over it because we're not as comfortable as I definitely want all of us to be. So that's fine. Something to the world. We'll go back before the test and talk more about it, but I'm going to keep pushing forward today with point-slope form. Point-slope form is a little bit weird. It looks like this. Y minus y sub 1 equals m times the quantity x minus x sub 1. It's a little weird looking. We know that m is the slope of the line. And the coordinate pair x1 comma y1 is a random point on the line. All right. Now, I know I said random point. It's whatever point that they give you, okay? But if we're talking about a line, right, there's an infinite number of points. All those points will work out in the same way. We'll see what I'm talking about in just a second, okay? Okay. If I am asked to write the equation in point slope form, for the line with a slope of three, that goes through the point 2,5. I'll obviously give you some time to get that copied down. Everybody got that written down? Okay. Real easy. How many numbers are we given in this question here? Given 3. What's my m? 3. What can I, prescribe x sub 1 to? 2. And who can I assign y sub 1 to? 5. Right? I've got a slope and I've got a point on the line. x1 comma y1. So I'm going to take my formula. My formula says, and just so we know, and if we're watching back on this video, right, when I'm writing a formula like this, anything that I write in black stays that. So the other day when we did this guy, right, the y equals and the x are black, they stay as y equals and x. Whatever is in a certain color is what gets replaced with a number. You guys notice that? See that? Okay, so if you're ever looking back, again, that's how you can tell, wait, where do I plug something in, where do I not? What are the three things that are colorful that I'm plugging into this formula? Y1, M, and X1. You can't just say Y and X, because Y and X are staying as Y and X. Okay? So, I'm going to rewrite it. Y minus Y1 equals M times the quantity X minus X1. All right? And this is going to turn into Y minus, what's Y1 here? What's my Y sub 1 from the problem? 5. Y minus 5 equals, what's my M? 3. Times the quantity X minus, what's my X sub 1? 2. And there's my equation in point-slope form. What were the directions in this example? It says write the equation in point-slope form. Did we do that? Then that is our answer. A lot of times our brains kind of go on autopilot, and I was seeing this when I was looking at B052, where we really, really have to read what the question is asking us to do. Okay, some of you will just see a slope and a point and just plug it in and start doing stuff without even reading what it is you're supposed to do. You have to make sure you're reading what to do to know when you're done. Right? Any questions about that? I know it looks weird. I know it's ugly. We'll talk about where we're going with it later. Right now, I just want us to get comfortable with the form. Let's do another example. Let's write the equation in point-slope form for the line that crosses through the points -3, +1, and +1, +9. A little bit different. A little bit different than the first one. First example was nice. It gave me a slope and it gave me a point. That's all I need to know to write an equation in point-slope form. That's why it's called point-slope, right? What did I need to know in slope-intercept form? The slope and the intercept. What do I need to know in point-slope form? Any point on the line and the slope. Right? That's why it's named that. Standard form, let's not worry about that. Okay? So I got 2 points. Well, I know one of the points. I could use any of these points for my point, but what do I not know? The slope. I don't know the m. Do I know how to find the m? Yeah. What can I use? The slope formula. That's right. The slope formula, which says y2 minus y1 over x2 minus x1 is going to give me my m. I'm going to label my little guys here as x1, y1 and x2, y2. Am I going too quick? No? Okay. So when I set up my slope formula, what am I going to plug in for y2? 9, thank you. What am I going to plug in for y1? 1. Bless you. What am I going to plug in for x2? 1. And what am I going to plug in for x1? Negative 3. What happens with these two minus signs that are kissing on the bottom? What do they make? They make a positive. Right? Big old positive sign. 9 minus 1 gives me 8. 1 plus 3 gives me 4. What is 8 over 4? 2. Can I box that up and move on to the next question? Am I done? No. What are the directions in this question tell me to do? Write the equation in point slope form. So I've got my slope. Do I know a point on this line? Yeah. As a matter of fact, I know 2 points on this line. Which point should I use? Matthew? Why the first one? I love that. Anyone else think that immediately? Same as Matthew? Yeah, it says x1 and y1. So I'm going to plug in, obviously, x1 and y1. Right? What if I had written this point first, and this was my x1, y1, and this was my x2, y2? Which one would I use then?
The one on the right.
This one?
Yeah.
Because it was labeled x1, y1?
Yeah.
Sure. Let's see what happens with them both. Okay? So I know my slope. I know my point. Here is option A. Option A, I'm going to use the very first point I'm given, negative 3, 1. And I'm going to write y minus, what's y1? I'm looking at this first point here. 1 equals, what's my m? 2 times the quantity of x minus x1. But what is x1? Negative 3. So what does a minus negative 3 give me? Plus 3. Plus, 3. All right? That's one answer I could have. I also could have option B. For option B, I'm going to use my second point. They're both points on this line, so I should be able to use that second point as well. Let's see. Y minus, what's y2 now? 9 equals 2, which is my m still, times the quantity of x minus, what's my x2? 1. So I have two possible answers here for this problem. But for this line that we're talking about, how many possible answers do I have?
2.
2? For this line right here that goes through these 2 points, How many different ways could I write this equation in point-slope form? Infinite. Thank you. We said earlier there's an infinite number of points on any line, right? So if the point that I plug in is arbitrary, I can plug in any of those infinite number of points. This is extremely important to note because in slope-intercept form, there is only one way to write that equation for that specific line. On the contrary, point-slope, there's an infinite number of ways we can write it. Well, how does that even work? How can there be an infinite number of ways that we can write it? Great question, Mr. Church. Let me answer it. Let's write both these options out. I got to flip to the next page. If you have room, you could keep going. Let's do a little experiment here. Option A was the equation y minus 1 equals 2 times x plus 3. Option B was y minus 9 equals 2 times x minus 1. This is going to be kind of like a magic trick. Okay, I've got option A on the left, option B on the right. Again, if you have room on that page, just keep going. You don't have to rewrite this. I just had to move it over. What we're going to do is we're going to try and convert to slope-intercept form, which is y equals mx plus b. Okay? If I want to convert this into slope-intercept form, what has to be isolated in this equation, Oscar? The y. Is the y all by itself right now? No. Can I just add this 1 over to the other side and be done? Is there anything to combine that 1 with over here? Not right now. Not in the way it's presented. What should I do first here? Distribute. Great job. 2 times x and 2 times 3. Now I've got y minus 1 equals 2x plus 6. Everybody with me there? Am I going too fast? Okay. Now what can I do? Now I'm going to add the 1. Because I've got a 6 that I broke out of jail. Now I can combine it up. What is 6 plus 1? 7. Y equals 2x plus 7. Is that written in slope-intercept form? Yes, it is. All right. Questions on how we got to that slope-intercept form? Real easy little, 2 steps to solve it. Let's do the same thing over here. Let's distribute the 2. What is 2 times x and 2 times negative 1? 2x minus 2. What am I going to do now? Add 9. What is negative 2 plus 9? 7. So I'm left with y equals 2x plus 7. What do you notice? It's the same thing. Right? It's the same. I could take any single point on this line, and there is an infinite number of points on that line. I could take, 300 million something something, comma, 500 million something something, if that's one of the points on the line. If I plug it in point slope, distribute, and inverse operate, I'll still end up with y equals 2x plus 7. It's kind of weird. Okay? That's how we would convert it. Let's do another one. Someone say Jesus. I told you the problem must have been we didn't do enough examples, and that's why there was so much confusion. So let's do more examples. You agree with that? Thank you. Thank you. Let me see what else you're going to need to know how to do. That's what we did. That's what we did.
This is our homework?
Yeah. Let's convert. Let's do more. Let's convert. Now that we introduced it, convert the following equations into slope, intercept form. Oh, 3/8. Ah, okay. Perfect. Give it a shot. What do the directions say to do? Good question. Great answer. Take a few minutes, see if you can work through those. Get them converted. The second one might be a little nasty, but that's all right. Yeah. What? I should never, ever.
Wait, how didn't you get C?
Ever.
Oh, it's for A, for A. I think it's for B. I was like, I'll give you 2 B. I got 2 white.
See on this number on any.
So it's just -1/2 x, right?
Yeah, the answer is yes. Whatever you're gonna say, the answer is yes.
Common denominator. No? So this would be times 2 times 2.
I'm gonna start with 10.
I got it.
It would be 6.
I did that. I think.
Would it not be 6?
Okay, so common.
No, it looks fine.
I think
3/4 x plus 3/8. 56.
cross that out. So 3 and then 1 times 2, that would be 6.
50. You got a 30, 33? 7. 8. Well, -7, if I want to put it over 8, wouldn't that be -56?
Put it over 8. Where'd you get that? I distributed that and then that was 5/4 and then added 7.
I see what you did. You added 3/4 plus 1/2. You have to multiply.
I'm gonna go
Just when you distribute, you multiply. So if I distribute across the bottom and across the top, I get 3/8. That's good though.
Thank you.
It's a good mistake to make.
No, let's say this for what?
Whoa. What is 3/4 times 1/2? 6?
Because I thought you would do that.
If you're adding fractions, you need a common denominator, not when you're multiplying fractions. When you're multiplying fractions, you just multiply across the top, multiply across the bottom. You know what I mean?
So 3/8.
Yeah, good job. Then I gotta get a common denominator to add the 7 to the other side. Nice. Love that. Great job. Yes?
So then it's
Oh, did you add them?
I got it.
You don't need to make it a common denominator. If you're adding 2 fractions, you need a common denominator. But not if you're multiplying. We'll see.
Wait, why did I times it by 7? Oh, yeah. Because you'd have to make it a common denominator, you would have to make your calculation. How did you put that? 7 times 8 plus 59 plus 3. What plus 3? Oh,
And then you multiply 3 times 2.
so 59 plus 3.
So what was it called? Fraction? And then when you add it, that's when you have a common denominator. So you put 7, you put 1 under the 7, and then for the denominator, it's 8 but you also take the top. So it'd be 56 plus 3 from the 3/8. So then it would be y equals 3.6.
I'm tired.
Yeah, so 3 times 1 is 2. So 3.
And then now
And then you get plus.
Makes it look way worse.
And then that's when you find your common denominator. So you put the 1
Yeah,
or
it's 7. Yeah, 8 raised 1. So I'm multiplying 7 by 8. I'm trying 7.
7 times 8 is 5. Don't make me
Don't make me remember that. I was
So you see, so it's okay, math is kind of fun.
I've practiced it too.
We'll talk about it. All right.
Okay, I honestly have no clue. All I remember.
Take a look. Take a look.
Oh,
sorry,
yes,
sorry.
yes, yeah.
There should be a plus in it.
That it is there.
Okay. Real quick, before we get out of here, let's take a look at A. What am I distributing here in A? Negative 1/2. So y plus 3 equals negative 1/2 x plus 3. Because negative half times negative 6 is positive 3. Then I subtract the 3 over here. What is 3 minus 3? 0. Now, do I want to write plus 0 on the end? No. We want to leave it like that. Y equals negative 1/2 x. You're not the only one. There's multiple people that left plus 0. We don't need to write it. Doesn't make me as upset as seeing a mixed number, but I still don't want to see plus 0. Okay? What am I distributing in the second problem? 3/4. Let's do a quick little side lesson on how to multiply fractions. If I have 3/4, yeah, some of us definitely need to listen up. If I have 3/4 times 1/2, what do I do with my numerators? Multiply them. What is 3 times 1? 3. What do I do with my denominators? Multiply them. What's 4 times 2? 8. Very nice. All right, back to the problem. We got y minus 7 equals 3/4 x plus 3/8. There's a couple different ways we could go about doing this now. We know how to fraction bust a whole equation. I can multiply this guy by 2 over 2, and I can multiply each of these terms by 8 over 8. It's a little bit too much work, okay? All I need to do is add this 7 over to the other side, right? But I can't combine 7 with 3/8. I didn't mean to do that. I'm saying I got a 7 here and a 3/8 over there. Whatever. So I need to put the 7, I need to make the 7 into a term over 8. So can I just write 7 over 8? No. Let's do another sidebar. How can I turn 7 into a fraction over 8? Oscar?
So 8 over 8 is 1 of 7.
8 over 8 is 1. If I multiply something by 1, it doesn't change what it is, it just changes how I see it, right? This turns into then 56 over 8. All right. Now this is y minus 56 over 8 equals 3 over 4x plus 3 over 8. What am I going to add to both sides? 56 over 8. All right. Leaving me with y equals 3 over 4x plus 59 over 8. There's my equation in slope-intercept form. Over 8. What? I'll take a look at what you did in a second. Okay?